Hello everyone. Good morning and good evening. My name is Anand Pundichinappa and I belong to the University of Michigan Dearborn. I'll be presenting the issues and challenges of load balancing techniques in cloud computing, a survey which is done by Pawan Kumar and Rakesh Kumar. The source of this paper is in ACM. I provided a link in the presentation, and it's basically a peer-reviewed journal with quite high number of citations. Let's get started. My agenda for today is to provide the objective of this particular paper and show you how this is relevant to my course project. And I'll also be talking about the challenges in cloud, the types of load balancing systems, the load balancing metrics for evaluation, some of the load balancing policies that the load balancers adopt, and some of the techniques in load balancing, talking about the static and dynamic, more emphasis on the dynamic load balancers. And finally, I'll provide the result and conclusion drawn by the authors. So the objective of this paper is to provide a state-of-the-art review of challenges associated with the existing load balancing technique. And this will serve as a base for the researchers to develop more effective algorithms. So we all know what a load balancer does, right? So its main objective is to distribute workload equally among available resources. And some of the features of the load balancers are listed as you see towards the right. It does the workload distribution. It does auto provisioning and deprovisioning of resources. It tries to minimize the response time for the tasks that are getting executed. And overall, finally, it basically does reduce the energy consumption. So how is this paper relevant to my course project? So in my course project, I'm doing an IoT-based smart card system using cloud services. To put it simply, I have an IoT-based weighing scale that can measure the weight of the items that are placed on a weighing scale, and that could be numerous weighing scales. For example, if you take a household, that could be a minimum of 5 weighing scales for measuring the weights of milk or any other item that can be placed. So the idea is to have a threshold that would be continuously monitored against the weight of that particular item, and then procure that particular item so we never run out of stock. So it is quintessential for me to basically study the load balancing issues, challenges, types, and its metrics in detail, so I can design a flawless backbone system that can handle and scale to a dynamic load of incoming streams of data from IoT weighing scale. I'd like to first discuss the load balancing challenges in cloud. So the first challenge being the geographically distributed nodes. We all know that the data centers are geographically distributed, and one of the challenges is handling nodes that are distant apart. Some of the factors that has to be taken into account are the network delays, the communication delays, and the distance between the users and the resources. The second biggest challenge is the single point of failure, especially when the load balancers are designed with a single node being the central device that takes decisions. And just imagine when a central device crashes, then the overall computing environment gets affected. The third biggest challenge is in VM migration, especially when a physical machine gets overloaded. How do we migrate the virtual machine to a different physical machine? The fourth challenge is going to be the heterogeneous nodes. A heterogeneous node means a node which can host virtual machines of different parameters. For example, it could be a processor architecture or an operating system. So this is one of the biggest challenges for a load balancer. And talking about the storage management, we all know that the cloud storage has relieved users from the data management and accessibility problems. But the challenge for a load balancer is to distribute the application and its relevant data accordingly. And finally, talking about the scalability, a load balancer should adapt to quick changes in demands in terms of computing power, storage, and system topology, which is going to be a challenge. Now moving on. There are two load balancing techniques at a 10,000 foot view that's discussed in this paper. One is static, the other one is dynamic. The static load balancing systems are a rule-based system. They don't take the current system state into account, which means they don't know the resource consumption of each of the nodes. It simply takes a rule-based approach in terms of allocating or deallocating resources. So it does not has any prior knowledge of the resources. One of the pros is that it's easy to implement, but then they are not suitable for distributed systems. When you take the dynamic aspect of the load balancers, they consider the state of the system, and more importantly, they provide the task transfer from an overloaded node to an underloaded node. The dynamic load balancers are very flexible and it improves performance, and they work very well for a change in demands. And we are going to talk more about the dynamic load balancers, and they are more practical and scalable. So the paper discusses 9 metrics for evaluating a load balancer. So one of the common or the highest metric being the performance that measures the load balancer system effectiveness compared to other load balancers. The second metric is the response time. This determines the total time taken to complete a submitted request. The third one is the throughput, which measures the total amount of submitted tasks completed in a particular unit of time. And the fourth one is about the scalability, which is the capability of the load balancer to accomplish uniform load balancing when demand increases. The other metric is the fault tolerance, which is very important. It's the capability of the load balancer to perform uniformly during breakdowns of a link or nodes. And talking about the migration time, this measures the total time taken to migrate a request from a overloaded node to an underloaded node. And then the resource use, this maximizes or measures the total usage or proper usage of resources to reduce the overall energy consumption. Degree of imbalance, this measures the heterogeneity across virtual machines. And then make span, which is the last metric that measures the total time taken to allocate resources upon a user request. Now talking about the load balancing policies, there are 4 policies that are laid out in the paper. The first one is the selection policy, then we have the location policy, the transfer policy, and the information policy. The selection policy identifies tasks to be transferred from one node to the other node, and the selection is based on various parameters like the total migration time, the number of non-local system calls, and the task execution time. The location policy determines the computing nodes that are underloaded or free, and the destination node for migration is selected based on 3 parameters or three different techniques: random, probing, and negotiation. In the random method, the selection of the destination node is done randomly, and in the probing method, the overloaded node probes other nodes to basically check whether there are underloaded nodes and then does the migration. And in terms of negotiation, the nodes negotiate with each other, which means it's not just the overloaded node, but the nodes can talk to each other and then negotiate to share tasks. The third policy is about the transfer policy that determines the circumstance or a scenario to transfer the tasks. And this is done using 2 approaches. The first one being the last received, which means the last received task will always be transferred. And the second approach is all current tasks. So in this method, there is a rule or a rule-based system to decide the tasks be transferred. And the last policy is about the information policy. This basically keeps all resource information up to date in the system. This is used by other three policies that we discussed: the selection, location, transfer policy. And the information is basically used by the other policies. So the information collection is done using the below techniques: broadcasting. All the nodes broadcast information to other nodes. And the second technique is about polling, where a centralized node polls for information from the nodes on the resource usage from the nodes. And the third one being the agent. There will be a dedicated agent node that collects information from the rest of the nodes. As I said earlier, the emphasis will be on the dynamic load balancing techniques. The paper discusses various dynamic load balancing techniques. The first one being the general load balancers. In this technique, the paper discusses the VM migration and load estimation based algorithms depending on the various load balancing parameters. The second technique that's discussed is inspired from natural phenomena. It includes the genetic algorithms and based on honeybee, where the tasks represent honeybee and the food source represent underloaded nodes. And the third one being the hybrid load balancing techniques. They are developed to overcome drawbacks of static and dynamic techniques, yet preserving their features and their advantages. The hybrid techniques mainly focus on minimizing the response time and provide efficient resource use compared to the other techniques discussed so far. And then we have the agent-based load balancing techniques. Here we have an agent that works for cloud resource discovery, negotiation, composition, and management. And the agent works automatically and continuously to satisfy a particular design objective. Compared to rest of the other techniques we have discussed, the task-based load balancing algorithm is a bit different. So the other load balancing techniques migrate the entire virtual machine from an overloaded physical machine. But in task-based load balancing, only the tasks get migrated, but not the entire virtual machine. So this is totally different from what we have discussed on the other techniques. Finally, we have the cluster-based load balancing techniques. In a heterogeneous cloud environment, various resources are placed at different data centers and are divided into different clusters based on the performance of the servers and storage capacity. And these techniques talk about the clusters based on the performance of servers and the storage capacities. Okay, so this is just providing more details to the previous slide where I spoke about different balancing techniques, load balancing techniques on the dynamic load balancers. So similarly, more details here on the various techniques. This is the last slide demonstrating the results and conclusion. You can see here the different load balancing techniques that we discussed satisfying different metrics. For example, 9% of the load balancing techniques that we discussed satisfy throughput, and similarly 13% satisfy migration time. Although it's quite surprising to see that only 2% of the load balancing techniques that we discussed satisfy fault tolerance. To conclude, the authors feel that there is a dire need to improve the load balancing techniques for increasing the overall system performance in the future. And in addition to that, we also need algorithms focusing on green computing, energy saving, and task load management. With that, I'd like to say thank you to everyone for your patience, and thank you for listening.